So now, what I would like to talk about is I want to go and talk a bit about conductors and insulators. Okay. And so what we get is that in a conductor, the outer electrons essentially loosely held in place. And I don't have I guess at the office I have this little matter model where you have little beads held in place with little springs that allow them to move that, form a little crystalline structure type of idea. I always like that one, but I don't happen to have it here, unfortunately. And so with the matter model being beads and springs, then that's kind of nice. It has a different feature in illustrating how the atoms behave than when you do usually the ball and stick models that you get in like the bio and the chemistry kind of classes. Because what you get is that those bonds between the atoms are electromagnetic in nature due to the sharing of our electrons. And what will happen is that they can actually move. And so the atoms themselves do move due to the temperature of the object. They sit there and they vibrate in place, kind of like little kids on sugar trying to sit still in seats. They sit there and they wiggle around. And so then you get this, change in the bond length between the two atoms is kind of somewhat variable. Okay. But what they have is that in equilibrium, they have some sort of average bond length, which is the separation between the atoms, but they sit there and they wiggle around in place. And so what you can picture is that as you increase the temperature, they're going to wiggle even faster, which then means that they're going to in general move further apart, and they will often interact with each other more often. And so what'll happen is that basically due to this, thermal motion of the atoms in the conductor, and they have these loosely held outer electrons, then some of those electrons can get kicked out of a particular atom. Okay. Now they're not kicked out of the material itself, they're just bumped out of the particular atom they were bound to, loosely bound to. And so then these are still, like I said, they're still bound to the material, but they're no longer bound to a particular atom. And so what we can talk about is due to the thermal motion, of the atoms in the conductor. Some of the electrons are no longer bound to a particular atom. Still bound to the material. And these electrons that get bumped out of their atoms, these are the conduction electrons. So they're still bound to the material. And they say that they are free. Free to move basically throughout the material. So this is what happens in the conductor. Okay, you have these loosely held outer electrons that get bumped out of place. They're still bound to the material, but then since they're not bound to a particular atom, you can then move them around throughout the material. And these are your conduction electrons. And what we get is that in an insulator, the electrons are tightly bound. To their atoms. And these ones are not free to move throughout the material. Basically, bound in place.